Hello again. So here's an update on the STM32 Open Ventilator. This is a more detailed presentation. So, just like we said in the last video, it's designed around 3 servos that are pressing on an ambu. The 3 servos are actually providing redundancy to the system, because should any one of these go wrong, you're still going to be alright, as the 2 other ones would be certainly good enough. Also, the controller can sense the power consumption of the servos, so it will detect that one is missing. It could compensate. This is not in the code yet, but the hardware supports this already. So that's for the mechanical part on the right side. Of course, all the files are available online. However, we still have to do a few changes to them. I believe that the fingers should be a little bit longer. And also, one of the issues that we're having right now is that it leaves some marks on the ambu. So I'm worried that in the long run it will be a problem. So that's something to think about. Now, in regards to the microcontroller here, this one is an STM32F407. It's on a discovery board with a shield on top. On the shield, there is a graphic display. So, yes, just like I showed you last time, you can plot the pressure, and actually the graph on the upper side is the current used by the servos. If I press on it, if I get a chance to, if I press on it, you can see the current going up. It's the sum of all the 3 currents. They're all measured independently. Now, in terms of connectivity, you have 3 outputs for the servos. You have an output for the cooling fan that is cooling the servos right here. Then on the upper side, we will have more outputs. For now, we have an I2C port, and that's an analog input. There's another analog input, but I believe that in the next redesign, all the sensors are gonna go on the upper side. This is a serial connection. It allows you to connect it to your computer and plot the different values with more detail. So right now you can see all the sensors being plotted on a laptop. If you have the chance to have a laptop, that would be helpful. What else? The programming is done through the USB port that's connected directly to the disco board. The power supply is right here. For now, it needs to work at 7 volts, 7 amps. We're evaluating integrating the power converter inside the unit that might allow you to use any power from 10 to 20 volts. Well, this is something to think about again. Now, on the right side, we have an exhaust line, an exit line. This is where the gases escape. In order to keep the lungs inflated, the doctors require some back pressure, and in order to provide that, you should install some kind of a valve on this one. For now, a very simple system that does the job is just a glass of water with the tube being submerged inside of it. So that would provide some back pressure, and you can actually adjust it. However, you should also filter or sterilize the output somehow. This is another thing to look into. Anyways, I hope you like the video. What we would like to do would be to focus more on the development of the control unit and make everything else available very easily. And this way we'll be able to provide the unit at a really low price, and everything else can be printed locally Let me know if that's something that you're interested. If you think that the kit is more interesting to have the whole kit ready. Anyways, this is where we're at. I hope you enjoyed the video, and see you next time.